Hello, this is John Baugh again, and we're going to start working on Chapter 6 today. This is Lecture 10, and the topic for today is our first look at classes, at least a serious look that we're going to take. So, Chapter 6 in the book, A First Look at Classes, the topics that we'll be covering today are objects and classes, and also writing a sample class step by step. We'll talk about instance fields and methods, constructors, passing objects as arguments, overloading methods and constructors, scope of instance fields, and packages and import statements. So, the first thing we'll look at is objects and classes. So, we've talked about them and I've kind of explained them, so we'll formalize it a little bit further right now. An object exists in memory and performs a specific task. So an object exists in memory and performs a specific task. By memory, obviously we're talking about main memory, typically realized as random access memory or RAM. The objects we have will have two general capabilities. They can store data, and objects can also perform operations. So they exhibit attributes or things about the particular object, and also they have behaviors, which are the operations. So the data that they store in an object, the data that's stored in an object is often known as fields. The methods, or the operations that the object can perform are known as methods. So you've got the data, which is called fields, and then the operations that they can perform called methods. So you've already used objects. We've already seen the scanner object for reading input. We've seen the random objects for generating random numbers, and we've seen print writer objects for writing data to files. When a program needs the services of a particular type of object, it creates that object in memory and then calls that object's methods as necessary. So what's a class? Now, a lot of people use the term class and object interchangeably, but they are technically not the same thing. Classes are where objects come from. A class is code that describes a particular type of object. It specifies the data that an object can hold. So that, again, the data that the object holds is called the object's fields. It also describes the operations or actions that an object can perform. That's obviously the object's methods, so fields and methods. You can think of the class as a code blueprint that can be used to create the particular type of object. So if you have a blueprint of a house, you don't live in the blueprint, you live in the house. So the house is like the object, the blueprint is the class. Class is the blueprint. When a program's running, it can use the class to create in memory as many objects of a specific type as needed. Each object that is created from a class is called an instance of the class. So we can call them, if we ever heard the term, or if you ever hear the term class instance or object, they're the same thing. So class instance and object. So here's an example. We've used the scanner before. You use the data type of the scanner, and then have the keyword, the keyword scanner, which is the data type, not a keyword. Keyboard is the identifier. Then you use the new keyword to assign the newly created object's address into keyboard. Okay. When you say new scanner, you can pass it a parameter. This parameter basically says the data is coming from standard input. So what this looks like in a memory is that the variable named keyboard does not contain the scanner itself. It contains an address, and that address basically lives, the data for the scanner object actually lives at the address somewhere else in memory. So same thing with random. If you make a random class object, you have random rand equals new random. So it creates a random object in memory. This is just a variable that holds the address. This does not actually create this right here, this code just there, it highlighted in gray, does not actually create the random object in memory. This is what actually creates the random object in memory. You have new random. So the rand variable is just created by doing this. If you just say random rand, even if I put a semicolon after it, I would still have a variable named rand. But when you say equals new random, that creates the object in memory, and then the equal sign makes it so that we're assigning the address returned by the new operator to random, variable rand. We also have the printWriter class. This printWriter class, right here, we're creating an object called output file. We're saying it equals new printWriter, and it takes a string parameter. And this basically specifies the name of the output file. Same thing. Output file variable does not actually, just writing this does not create the printWriter in memory. It just creates a variable that can hold an address to a printWriter. When you say equals new printWriter of numbers.txt, what that does is it actually returns the address of the new printWriter object that it's created in memory. The Java API provides many classes. So we've seen several of these. The examples we just saw are parts of the Java API: scanner, random, printWriter, but there's many, many more. However, we can create our own. But first, let's take a look at what we can do if we use the ones provided for us. So we're going to go to Eclipse, and if you need to, you can create a new Java project. We've done it so many times, I just had it prepared beforehand. I'm going to right-click Source, go to New Class. In this class, I'm going to name Object Demo. Hit Finish. This is our object demo. I'm going to import the scanner, random, and also the IO, like all the IO classes. So scanner, java.util.random, java.io.star is the wildcard. That means that it gives you the class access to all of the classes within java.io. And inside of object demo, we're going to do private static void main, string array args, and also throws IO exceptions if we're going to be dealing with files. And now what do we want to do with this? Well, we're basically going to print some numbers to files, ultimately. Let's have max numbers, so that's max number of random numbers. Count int number, sorry. That's the hold a random number. It's going to be used to actually hold it before you print it. Create a scanner. And create a random. So I got rid of the semicolon there. Don't need that. I do need that. Random rand equals new random, and then create a printWriter to open file. Call it numbers.txt. Should be printWriter, not writey. We've got printWriter. We'll get the number of random numbers. Say system.out.print. I'm going to say how many random numbers did I write. Next numbers is equal to keyboard.nextInt. That will obtain an integer. It will obtain the number that the user enters. So we max numbers, not number. So my definition is actually wrong up here. The declaration is actually wrong. So it's supposed to be numbers. There we go. So right there we're going to obtain how many numbers the printWriter should print to file. And now what we're going to do is we're going to write the random numbers to the file. So which file? It's going to be numbers.txt. For loop. Number equals rand.nextInt. So what that does is that we obtain a particular random number here, and then once we've obtained that number that's randomized here, that's this variable that we're using up here, once we obtain that value, we write that value to file. Once we're done with the loop, we're going to put output file.close, because you're supposed to close it, make sure it flushes the buffer and all the data gets written to file. And then do a system.out.println, and we just want it to say done. So we know when it's done. So let's run this, see what happens. It asks how many random numbers do I want to write. Let's say 15. And then it says done. So it's done that fast. Now how do we know? Well, let's right-click the project and go to refresh. And you notice that automatically, I can now see it automatically adds this file that was in the directory, and we can see numbers.txt. It's obviously writing some random numbers to the file. All right. So we didn't specify any conditions on the random number generator, so it gave us all kinds of numbers. So the next thing, we're going to write a class, a custom class this time, because we've used some of the classes that have been made for us already. We've actually been writing our own classes, but these classes have contained main. So if we look here, we see that we've got public static void main. It is inside of a class, object demo, which is for the object demo.java. But we can make our own custom classes that don't even have main in them. So let's do that. We're going to create a rectangle object, and it will have the following fields. Now remember, fields are the data that are inside a class. You're going to have the length, which is the length of the rectangle's, that's the value of the rectangle's length, and then the width will hold the value of the rectangle's width. So that's data, or the fields. So what kind of behaviors or operations can the rectangle perform? Well, we've got 5 right here. Set length, which will store a value in the object's length field. Remember, we have the length field back here. We don't want to make this public because then users can put whatever they want in it. Maybe we want to eventually restrict them and show them what they can and cannot do. Same thing with set width. You want to be able to set the value, store value in an object's width field. You have a get length and get width, which correspond to obtaining the length and width field properties. And note that we have these because if these are private, which we talked a little bit about before, we'll get to more today, since length and width are private, that means that we need a get length and get width and set length and set width to interact with them. Now get area is a little bit different. Get area is not based on a single stored field. You don't store an area data right here. Instead, since we can obtain it by calculating, we will calculate the area as needed and return it to the user. In this case, the area is the length multiplied by the width. Often we use UML, or Unified Modeling Language, to provide a set of standard diagrams for graphically depicting object-oriented systems. So in a UML class diagram, we have the very, very top. There's like 3 sections of a square. The very top will contain the class's name. Then you will write the fields, and then you will write the methods. So let's look at the class diagram. A basic UML class diagram would contain length and width up here, is the fields. And then you'd have set length, set width, get length, get width, get area down here. So let's write the code for the class fields. We're going to start our rectangle class here. I'm going to right-click this default package. We'll just add it to the default, even though that's not always recommended. Got rectangle here. Just going to call it rectangle. Notice it does not have the main method, and we're not going to actually create a main method. We're going to use this class differently. So we're going to include the double length and double width. So they're both private. Double length, private, double width. And then the next thing we have to look at is the access specifiers. I have mentioned these before, but we want to formalize our notions of what public and private mean. An access specifier, in some literature known as an access modifier, is a Java keyword that indicates how a field or method can be accessed. How a field or method can be accessed is an access specifier. Public access specifier, when this is applied to a class member, which could be, now collectively we call fields and methods the members of the class. So when public is applied to either a field or a method, the members of the class, these members can be accessed by code inside the class or outside the class. So they can be accessed directly. They're available to the public. That's what the public access specifier means. The private access specifier is applied to the class member, and this member cannot be accessed by code outside the class. Again, the member, whether it's a field or a method, those are the members, whether it's fields or methods, if they are labeled with the private access specifier, they cannot be accessed by code outside of the class. So the member can be accessed only by methods that are members of the same class. So here's an example. This would be the header for the setLength method. Since we want the outside world to have access to setLength, in other words, when we create an instance of our rectangle class, just like we create an instance, an object of the random class or the print writer class or the scanner class, we want to be able to interact with it. So since this method that we're defining is public, that means that the outside world has access to it. The return type follows the access specifier. In this case, it's void, which means this particular method does not return anything. Then you have the method's identifier, or the method name, setLength. And then you have a parameter list. In this case, there's only one parameter. It's a double, and that's the value that we're going to set our internal field length to. Notice the word static does not appear in the method header designed to work on an instance of a class, the instance method. So in the class that we've dealt with that has the main method in it, that method has to be static, which means it is shared by all objects of the class, and even if there are no objects of the class, it can be automatically called. So when you execute your program, it calls that static main method and pulls all necessary resources into memory and then executes the method. But for this, in this case, we don't have static, so it's called an instance method. If it didn't have static, which is normally probably more often the case, when it doesn't have the static keyword, if it were a piece of data, we would call it an instance variable or an instance field. So let's write the setLength method. So inside of here, we've got our fields already, right? Now we want the methods. So one of the methods is public void setLength, and it takes a double. This does not require this comment I'm putting at the end. I usually do this just to keep things a little more clear and concise. Comprehensive, self-documenting. So all we do inside of setLength is we set the length equal to len. Okay, whatever the user passes in this case, let's say it was a 15.7, we can set our internal field to whatever the user passed in. Because in this method, this length variable is global to the class. So that means if we're in an object, that object, as long as it's alive and doesn't modify it again, that length variable will be set to whatever they set it as when they call setLength. If we wanted to create a rectangle object, we would call rectangle box, and this is whatever name we want it to be. It could be rectangle bedroom, rectangle pony, rectangle sausage, whatever actually makes sense. Not all those make sense, but we would say that equals a new rectangle. And in this case, they're using the word box. So that's the identifier of the particular object of type rectangle. This box variable holds the address of the rectangle object. So box holds the address, and that points to essentially the actual rectangle object in memory. By default, the length and the width are set to 0. Later on, if we call the setLength that we just defined, the box variable holds the address of the rectangle object. The rectangle object will look like this if you call setLength to it. So if you call setLength, what that does is it calls the method we just defined earlier, where we set length, the internal length, to whatever the user passes in. In this case, the value they're passing in is 10.0. That value is stored in len temporarily. This is essentially a local variable, double len, to this method, and then all you're doing is you're taking advantage of it and you're setting your internal length variable to this temporary parameter variable here, len, and then it will actually change its internal value. So this is the state-of-the-box object after the setLength method executes. So we've taken a look at the setLength method, which is sending data into the object of the class. But we also want to take a look at the getLength method. The getLength method allows us to obtain the rectangle object's length field. So for getLength, if we go back to our code here, public, and this time it's a get method, so that means it returns a particular value. In this case, it's going to be double getLength, and it doesn't take any parameters because you're not sending any data into the class, you're obtaining data from it. Now you notice it'll actually highlight this and it'll say this method must return a value, a result of type double. So I've got to return the length. That's what I want to return with getLength. So what about getArea? Well, the getArea method returns a rectangle object's area. This is the length times the width. So I'm going to go back in here. We probably also want to be able to write the set width and the get width methods first. So let's do that. I'm going to write the set width. I'll just put WID. And then inside here, you set the internal data member, the internal field width to WID, and then public double get width. This one just returns the data member width. Now, area, as we were talking about, actually returns the rectangle's area. Now, this is not returning a single field. What it's doing is it's actually performing a calculation and returning that. Now, you could put the result of this calculation, length times width, in a separate variable and then return that variable. So, for example, I could say int a equals length times width and then return a. But they're just skipping the middleman here, and this is often the case. You'll see them just write the formula right here. So since the area of a rectangle will produce a double, possibly, we'll put area. I think maybe they called it getArea. getArea. Yep. getArea. getArea returns the width times the length. All right. So because of the concept of data hiding, fields in a class are private. The methods that retrieve the data of the fields are called accessors. So those are the ones that get the data. They access it. The methods that actually modify the data of the fields are called mutators. So accessors get the data, mutators modify the data. Each field that a programmer wishes to be viewed by other classes needs an accessor. Each field that the programmer wishes to be modified by other classes needs a mutator. So again, if you just want the data to be read or observed from the class, you have to implement an accessor, such as getLength, getWidth. If you want to be able to modify that data, you need a mutator. So setLength, setWidth. For the rectangle example, the accessors and mutators are setLength and setWidth. These are both mutators, and then you have getLength and getWidth. Those are both accessors. So getLength and getWidth. Other names for these methods are getters and setters. So we would say that the getLength and getWidth are getters, setLength and setWidth are setters. Data hiding is a concept within object-oriented programming. An object wants to hide its internal private fields from code that is outside the class that the object is an instance of. Only the class's methods may directly access and make changes to the object's internal data. Code outside the class must use the class's public methods to operate on an object's private fields. Okay, I'll read it again. Code outside the class must use the class's public methods to operate on an object's private fields. Data hiding is important because classes are typically used as components in large software systems involving a team of programmers. Data hiding helps enforce the integrity of an object's internal data. Now, what is stale data? Stale data. Some data is the result of a calculation. For example, an area of a rectangle is length times width. It would be impractical to use an area variable here. The data that requires the calculation of various factors has the potential to become stale. To avoid stale data, it's best to calculate the value of that data within a method rather than store it in a variable. So at one point, you might end up with the data being calculated, a length variable or width variable might get updated at some point, and then the calculation won't be performed again. So to prevent the data from becoming stale and increasing unnecessarily the size of the class, we just calculate it as needed. So in the case of get area, we just return width times length. We don't make a private field called area and then calculate it every time we perform any kind of operation. That would be impractical. So again, rather than use the area variable, we dynamically, in other words, on the fly, calculate the value of the rectangle's area when the method is called. Now, any change to the length or the width variables will not leave the area of the rectangle stale. So if we use the UML data type and parameter notation, we saw UML a little earlier, the class diagram, but now we're getting a little more specific. UML diagrams are language independent. So that means you could use them for Java, for C++, for C, for C#, for Visual Basic. UML diagrams use an independent notation to show return types, access modifiers, etc. So if you see a minus sign, use the access modifiers first. The minus sign means private, the plus sign means public. So if you see a minus sign, which usually is in the, pretty much most of the time you will see the fields are generally private and the methods are generally public. This is not always the case, but it is a typical usage in many scenarios. So we'll see minus, and then you have width of type. That's how you read the colon, double. So notice that the data type is after the variable name, and then there's a colon in between. Again, this is UML diagram notation. It is not Java notation. For set width, we see that the entire set width method, that's its name, so the identifier goes first in fields and methods. Then you have the of type, and then you have void in this case. That means it's a void set width method. Now the parameters are written similarly. We have a double parameter that's named W, so we say W and then of type double. So UML diagrams, we have the variable types are placed after the variable name separated by a colon. Method return types are placed after the method declaration name separated by a colon. Method parameters are shown inside the parentheses using the same notation as variables. So converting the UML diagram to code. How do we take this UML diagram and actually convert it into code? So we put all this information together. A Java class file can be built easily using the UML diagram. UML diagram parts match the Java class file structure. You have a class header with the class name, the fields are the same in the UML diagram as in the Java file, and then you have the methods. You just have to use Java syntax, not UML syntax. So for here, the structure of the class can be compiled and tested without having bodies for the method. You just have to put in dummy variables if you need to without the full implementation. But here's the full UML class diagram, and here's the full code, even without bodies. So notice they put a return 0.0, just a default value for the width, length, and area, because we just need something to make it compile. That's basically what they're doing there. And then you actually put in the data. So here they put double W. I could change that back if I want to, change it over here to W. So that's fine, just to remain consistent. So the next thing are class layout conventions. The layout of a source code file can vary by employer or instructor, but the common layout for a Java source code file is that you put the fields first, then you put the methods listed afterwards. The accessors and mutators are typically grouped. So you have I tend to alternate. I tend to, I guess it depends on the scenario, but sometimes if these two are related to the length variable, which they are, the length field, I tend to group these two together, even though one is a mutator, the set length, and then one is the accessor, the get length. Same thing with set width and get width for the width. And then get area is down here by itself, calculated. But some people tend to form them that way. So there are tools that can help in formatting layout to specific standards. Instance fields and method. Fields and methods are declared as previously shown, and they're called instance fields and instance methods. Objects created from a class have their own copy of instance fields. Instance methods are methods that are not declared with the special keyword static. So if you don't have the keyword static there, they're known as instance methods. So all the methods we wrote in here in this rectangle.java are instance methods. None of them have static on them. That means every time you create a rectangle object, each of these will use these instance methods to return the specific copy of data that is contained within the length and width, or the calculated value, get area, based on the length and width. So the states of three different rectangles. Let's say we have a kitchen variable that holds the address of a rectangle object. The bedroom variable also holds an address of a rectangle object, and also the den. So if we might be using this rectangle object just to show the length and width of different rooms. So we'll say the kitchen is 10 by 14, the bedroom is 15 by 12, the den is 20 by 30. You have the address contained in the actual variable. So the kitchen variable is represented right here. And then what you do is you actually point to the object in memory, which has length and width fields in it. Well, what's a constructor? Well, classes can have special methods called constructors. A constructor is a method that's automatically called when an object is created. Constructors are used to perform operations at the time an object is created. Constructors typically initialize instance fields and perform other object initialization tasks. Constructors have a few special properties that set them apart from normal methods. Constructors have the same name as the class. They have no return type, not even void. Constructors may not return any values, and constructors are typically public. So here's an example. A constructor for the rectangle class could look like this. You might define public rectangle. Notice there's no data type, no return type. Then you can have parameters just like you do with any other method. In this case, when the rectangle is created, we want the user to be able to pass in length and width. By default, Java creates a default constructor, which we'll talk about in a little bit. But if you create any kind of constructor and you define it, it will not create the default constructor. So let's do this. Public rectangle. It takes double len and double w. So we have length equals len, width equals w. So that's our constructor right there. Notice there's no return type. So in UML, the most common way constructors are defined is pretty much the same. It's usually no return type, or it isn't a return type, and it's usually the first item in the list, in the class diagram. Uninitialized local reference variables. Reference variables can be declared without being initialized. So you could declare a rectangle box here, this box variable of type rectangle, but the statement does not create a rectangle object. It just basically you're creating a variable that can hold the address that points to, or that can the address actually is the address in memory of the rectangle object itself. So it's an uninitialized local reference variable. Right now, if I just say rectangle box or random r or print writer pw, if I just put the semicolon after there and do not have a new statement, then it does not create a rectangle object or a corresponding object. A local reference variable must reference an object before it can be used, otherwise a compiler error will occur. For example, if I say box equals new rectangle of 7.0 and 14.0, The box will now reference a rectangle object of length 7 and width 14. So now we should look at the default constructor. When an object is created, its constructor is always called. Always. If you do not write a constructor, Java provides one when the class is compiled. So we haven't seen code that's using the rectangle yet, but similarly, if I used one of the classes, the other classes, if they accepted the default parameter, they would use the default constructor if there was no parameter. And we can see that if you don't write the constructor, Java provides one when the class is compiled, and that's known as the default constructor. What it will do is it will set all of the object's numeric fields to their 0 value. Now, if they're any kind of number, it's the 0 value. All the Boolean fields will be false, and it'll set all of the object's reference variables to the special value null. So any references, it'll point to null, which basically means it's not pointing to an address. It just says it's pointing to null. The default constructor is a constructor with no parameters used to initialize an object in a default configuration. The only time that Java provides a default constructor is when you do not write any constructor for the class. So if we had not written this rectangle constructor right here, Java would have provided a default constructor. A default constructor is not provided if the constructor is already written. So you can write your own, what the book is referring to as the no-arg constructor. To be perfectly honest, most of the literature will still call a constructor with no parameters. It will call it a default constructor still. It's just not a compiler-generated default constructor. But the book is referring to it as a no-arg constructor, and then they're saying the default constructor is a no-arg constructor provided by the compiler. So a constructor that does not accept arguments is known as a no-arg constructor. The default constructor provided by Java is a no-arg constructor, and we can write our own no-arg constructor. So let's say we want to have a no-argument constructor, or what most of the literature would just call a default constructor. Set the length equal to 1 and the width equal to 1. Say that's the default size of our rectangle. In this case, it would be a square, very small unit square. So what about string? Well, the string class constructor, one of the string classes, class constructors accepts a string literal as an argument. This string literal is used to initialize a string object. For instance, we could say string name equals new string and then pass it Michael Long. This creates a new reference variable name that points to a string object that represents the name Michael Long. But because they're used so often, string objects can be created with a shorthand. So this almost looks like you have a value type variable rather than a reference variable. But you have to understand that this is basically just a shorthand used in many programming languages, the Java language in particular, because they're used so frequently. They made the shorthand, so it's a lot easier than it's a lot more clean than using the parentheses. Okay, so just saying string name equals, and then you call this. But what's really being called and what's really happening is it'll call some version like this. It'll actually, the compiler will generate code that's similar to this. So it's just a shorthand. So passing our objects as argument, when you pass an object as an argument, the thing that is passed into the parameter variable is the object's memory address. As a result, the parameter variable references the object, and the receiving method has access to that particular object. So that means you can actually modify the object. Two or more methods in a class may have the same name as long as their parameter lists are different. This is called overloading methods, or method overloading. So this would apply to constructors. So you'll notice right here, our constructor, for example, we have a default constructor, or a no-arg constructor is what they're calling it in the book. You also have a constructor, rectangle, same exact name, and the only difference is that it has a different parameter list. You could also make a different set length or get area or anything that makes sense, but it has to have a different parameter list. It cannot just vary by the return type. For example, I can't have a public int get length with no parameters here because the return type is not considered part of what's called the method's signature. So you would have to have a different parameter list. Now that could mean you could have two methods that have the same name and one parameter, but the parameters have to vary. For example, it has to be an int or a double or some other data type like a string. But if they have the same name, that's okay as long as they vary in their parameter list. It could also vary by number of parameters. So you might have one with one integer, one that takes two integers, one that takes three, etc. This is called method overloading. So method overloading is important because sometimes you need several different ways to perform the same operation. Here's an example. Let's say we have a method named add. Public int add. It adds int num1 and int num2. Now this is part of the signature. The word add, which is the method's identifier, and then the two methods that are the two variables that you pass in, the parameters, int num1 and int num2. What they're doing in the method is they're summing the numbers and then returning the sum. Now you might have another method, this time it's also named add, but it takes two string parameters. When we take this, they're actually concatenating the strings and then returning the combined string. The method's signatures consist of the method's name and the data types of the method's parameters in the order they appear. The return type is not part of the signature. So if you have any two methods that have the exact same parameter list, it's going to cause a compiler error. The process of matching a method call with the correct method is known as binding. The compiler uses the method signature to determine which version of the overloaded method to bind the call to. With constructors like we have in our example, with the two constructor examples that we have here, we added the noArg constructor. We also have the other constructor that we created. If I call this one right here, rectangle box equals new rectangle, this calls the default constructor because it has no parameters. This one down here, box 2, this one calls the constructor that has the two parameters. So this first one calls the noArg constructor, or what I would call the default constructor, and then this right here we'll call the version with the two parameters. So first call uses the noArg constructor, and the box will be assigned length 1 and width 1 because that's what happens inside of this method here. And then the second call would use the other constructor, and box 2 would have a length of 5 and a width of 10 because it would use this code right here. Then they go through a bank account example. We'll skip that one for now. Scope of instance fields. Variables declared as instance fields in a class can be accessed by any instance method in the same class as the field. If an instance field, that means a field that belongs to a specific object, is declared with the public access specifier, it can also be accessed by code outside the class as long as an instance of the class exists. There's a topic called shadowing that you need to be aware of also. A parameter variable is, in effect, a local variable. So when we have a parameter in, for example, set length here, this parameter actually acts as a local variable. Within a method, variable names have to be unique. A method may have a local variable with the same name as an instance field. So that means this variable, I could declare a variable in here or as a parameter, and I could name it length if I wanted to, because that's the same name as an instance field. However, I cannot create another local variable in here. I can't say double length inside here because that will conflict, or double len inside here, that will conflict between the parameter and between the local variable. So this is called shadowing. If the method has a local variable with the same name as an instance field, it's called shadowing. The local variable will hide the value of the instance field. So if I have a local variable or a parameter with the same name as the instance field up here, the local variable or parameter will be the one that gets the that will be referred to if you use its name. So if I say length, that's kind of ambiguous. Do I mean the field, the instance field, or do I mean the parameter or local variable? Well, it'll use the more local version. Shadowing is discouraged, and local variable names should not be the same as instance field names. So what about packages and import statements? Well, we have explicit and, the classes in the Java API are organized into what are called packages. So you'll hear a lot about Java packages. Explicit and wildcard import statements are the two different types you can use when you're importing. We see a couple here, not in the rectangle class, but in the object demo we looked at earlier. We see two explicit, in other words, java.util.scanner. We're specifically importing java.util.scanner to use the scanner. We're specifically importing java.util.random to use the random class. But right here, import java.io.star, the star is what we call a wildcard character. That means that we can access any of the classes that are inside this level of the java.io. So explicit imports name a specific class. The wildcard imports name a package followed by a wildcard, which is the asterisk. Notice that the java.lang package is automatically made available to any Java class. We don't need an import statement in that case. And this is just a list of some of the standard Java packages: applet, AWT, IO, lang. That's the one that's automatically imported. .NET, security, SQL, text, util, which has the scanner, for example, and the scanner and the random classes that we've used before. IO has the print writer that we've used. And we've got javax.swing as well. A simple note about object-oriented design. Finding the classes, there's a technique called finding the classes. You want to get a written description of the problem domain, identify all the nouns. Each noun's a potential class. You refine the list to include only the classes relevant to the problem. So for example, like they do in the book, they say if someone has, for example, an automotive repair shop that specializes in foreign cars, especially, I think it was Mercedes, BMW, and Porsche. If they do that, then you could look through it and say, well, Mercedes, BMW, and Porsche are all types of cars. So let's just use car. Maybe car is its own class, but we don't need a separate class for Mercedes, a separate class for Porsche, a separate class for BMW. They're all cars or vehicles, right? You want to identify the responsibilities, things the class is responsible for knowing and doing. So knowing has to do with the fields that the class will take on. Doing involves behavior. So the knowing is more on the side of nouns. Doing is on the side of verbs. Okay. Refine the list to include only classes relevant to the problem. Now what about the responsibilities, though? Things a class is responsible for knowing and things it's responsible for doing. I don't know why it's doing this twice. That's really ridiculous. Interesting. So, yeah, that's really weird. All right, so basically this last slide is completely useless. So the only thing you need to know is finding the class themselves and then identify the responsibilities of the class. So all you need is the class's responsibility in knowing and doing, and then refine it so that we only know the relevant classes and the relevant behaviors and the relevant fields. This actually might be slightly off, but it's related. But you want to make sure that you have a list only of the classes relevant to the problem, and that you have also a list of the behaviors, the knowing, the doing, and also the data, which is the knowing. All right. So just as a quick usage of the object demo that we have in here, we probably want to make sure that it is used. Why does it say it's not used? Interesting. All right, so inside of rectangle, let's just say outside of rectangle, we're going to create another class. This time, we're going to call it rectangle demo, and then hit OK or hit finish. And for this one, we're going to actually utilize the rectangle. So in this case, I'm going to create a main method, public static void main, string array arbs, and then inside there, I'm going to create a rectangle box equals new rectangle, and let's say also I do this, I say box.setLength, and I'm going to set it to 10.0. I'm going to say box.setWidth, set that to 20.0. I want to probably spell width right. And then, let's say I want to do another one. I'll say rectangle. I'm going to do a modification of an example they have in the book. I'll say box2 equals new rectangle, pass it a 5.0 and a 6.5. We'll say. All right. System.out.println. We'll say box1. I'm just going to print box.getLength or getArea. And then I'm going to do system.out.println box2. Box.getArea. Run it, and then down here we can see that box 2 and box 1 both have two. Oh, box 2. That should be box 2. Sorry, run it again. There you go. That makes more sense. We have box 1 with 200 and box 2 with 32.5. All right, so that's pretty much for today. If you have any questions, please feel free to email me or visit the discussion boards, which I'm planning on taking a perusal of pretty soon. Your capstone project will be assigned next week. Again, hope you all had a good weekend, and hope you're rested up and ready for the capstone next week, and that you're having a good semester. Again, if you have any questions, just please feel free to give me an email and ask very deliberate questions, and I'll be glad to try to answer them. Thanks.